you have x2 minus x. X2 minus x. Then here, as it's coming like this, we have y minus y1. As we are going up like this, we are having y2 minus y. So these are the, now if you have to determine the midpoint of a line, so it implies that your x minus x1 is equal to x2 minus x. Then if you have this, then you have x, collect like terms, so you have x plus x, then you have x2 plus x1. Then this one becomes 2x equals to x2 plus x1. Then your x will definitely be half, or let's say your x will be x2 plus x1 divided by 2. Then your x now becomes 1 over 2 into x2 plus x1. That is 4. Then similarly, we have, this is the horizontal, then the vertical, we also have your y minus y1 equals to y2 minus y. So if you also collect the like terms, you have y plus y equals to y2 plus y1. And this one becomes 2y equals to y2 plus y1. And here we can have y to be equals to, by dividing both sides by 2, then we have y2 plus y1 over 2, which can be written as 1 over 2 into y2 plus y1. So if you are to consider the midpoint of the line segment, then we have, therefore, the midpoint, the formula for the midpoint of a line segment. The midpoint of a line segment will definitely be equal to 1 over 2. We have 1 over 2 into x1 plus x2, comma, then we have 1 over 2 into y1 plus y2. So this is the formula for calculating the midpoint of a segment. Now, a situation whereby you are given 2 points, let's say P to be 2, minus 1 and Q to be equals to minus 3, 4. And you're asked to determine the midpoint of this. You're asked to determine the midpoint of P. This is equal to this, comma. If you have to determine this, the first thing you do is you write your, what's this? You write, this is your Q, and this is your P. This is your point P, and this is your point Q. And you have to determine the midpoint of point P and Q. So automatically, if you have to do this, what you do is you just, this is your x1, this is your y1. You label your coordinates, then you have, this one will be your x2, and this is your y2. So if you are talking about, to determine the midpoint of a line segment of this, then it will be 1 over 2 into, what is our x1? x1 is 2, plus x2. x2 is minus 3, comma. Then we'll have 1 over 2, y1, what's our y1? Minus 1, what's our y2? 4. You have a situation like this, then which becomes 1 over 2. This one becomes 2 minus 3, comma, 1 over 2. This one will definitely be 3. So automatically this one is minus 1, so you have your midpoint will be minus half, comma, then you have 3 over 2. So This is definitely the midpoint of a line segment. So, and that is what we talk about. So they can give you numerous examples or numerous questions, and what you have to do is just to apply this formula. Once you apply this formula, your answer comes out naturally. It should be noted that in determining the distance between 2 points, where your denominator is 0, having calculated, and your denominator is found to be 0, or a scenario whereby, in a case whereby you have a fraction such that you have 1 over 0 or 0 over 1. 1 over 0 is definitely going to give you, it will be undefined. This is undefined. That means you cannot find the real values for this. Then 0 over 1 is equals to 0. So that's the point I'm trying to make there. That is, when you have 1 over 0, it is undefined. So take note of that. The next subtopic here is the equation of a line. You have equation of a line. The model is y equals to mx plus c. This is the model of the equation of a line, where m is the gradient or slope, and c is the intercept. Usually your y-intercept, your y-intercept, that is y at the point where x is equal to 0. So this is the model for equation of a line. So now, a situation can be given whereby we'll be asked to determine the equation of the line. Example 1. Let's say we have to find the equation. We have to find the equation of a line whose slope is equal to 2, and the point Q is point 2 is minus 1,3. For example, so if you are asked to find the equation of line for this scenario, what we need to do is that, since we know that we have the formula, which is the gradient at a point, and the formula is given as y minus y1 equals to mx minus x1, and this we treated in the SS2 class. If you can still recall, then in this scenario we have our x1 to be equals to minus 1, our y1 to be equal to 3. Remember, our slope m is given as 2, so we can impute all these values, known values, into the model, and our equation comes out naturally. We have y equals to mx plus c. So our y we have here is what we have to use as a template. Then here you have y minus y1. What's our y1? 3 equals to m2 into x minus x1 minus 1. Then we have y minus 3 equals to 2 into x plus 1. Then here we have y minus 3 equals to 2x plus 2. Then at this point, we can write this as, by collecting like terms, then we have y minus 3, or by bringing everything to one side, we have minus 3 minus 2x minus 2 equals to 0. correct. Y minus 3, then this one comes to there, become minus 2x, and this one comes to there, becomes minus 2. So we can, this and this, minus 3 minus 2, that's minus 5. Y minus 2x minus 5 equals to 0. So this is the equation of the line. And that is how to determine the equation of the line, provided one point is given. You can see in the question, it is evident in the question that we are given only 1 point. That is why we have to apply this model for determining or for finding the equation of the line. But sometimes, or however, we can be given a scenario whereby 2 points will be given. Let's say you have Q, or we have our P given. Our P given as 2, minus 4, and our Q remain the same, minus 1, 3. And we have to find the equation of the line. Find the equation of these points. I have to find the equation of these points. As we find the equation of these points, then here we have y minus y1 over x minus x1 equals to y2 minus y1 over x2 minus x1. That's what we're going to have. And we are to p is 2, minus 4, where this one is x1, y1. Q is minus 1, 3, where this one is x2, y2. So let's substitute or impute all these values that are known into the model. So y remain minus y1 as minus 4 over x minus x1